All right, we're going to jump back. We spent one day on this earlier in the year, so we're going to come back to it and spend some time with it during this week. We're looking at literal equations. So, literal equations, if you recall, are equations that are going to have multiple variables. They might have a number, but oftentimes it's like a formula that has numerous variables, and it's solved for a variable. So, what we're going to do is we're going to solve it for a different variable than it's already solved for. And we're going to do that just through our basics of equation solving and keeping things balanced. So we're going to go ahead and look at number one. We have z equals m times a, and they want us to solve for a. So if I thought about this as just a number equals a number times a, and I wanted to solve for a, I would first have to undo multiplying by m. So we would divide by m, and these would cancel. We would be left with a equals, I can't divide z by m, so I just leave it as z divided by m. And that would be our final answer. So this is an equation solved for a. So it's a equals z divided by m. Let's look at number two. G equals a plus c. And we want to solve for a. Okay, so we're going to solve for a again, which means we want to isolate a, get everything away from a. First thing we're going to do is we're going to subtract c. That leaves me with a, and I should have drawn a line down the equal sign. A equals. Now g minus c, these are different terms, so I can't combine them. So I'm going to write it as g minus c. And this would be my final answer. So again, this is solving literal equations for an indicated variable. We're going to do a couple more refresher examples. Number three, I'm solving for x. A couple more steps involved here, but just one step at a time. I want x by itself, so I need to solve for x, which means I need to undo this minus 3c and minus 2. So I'm going to go ahead and I'm going to plus 3c first. That's going to leave me with m plus 3c equals, I'm going to keep my negative on the 2 plus x. Now I got to get rid of the negative 2 by adding 2. So that leaves me with m plus 3c plus 2 equal to x. And this would be our final answer. We'd leave it in that form. Number four, z equals negative 6x minus 3a divided by 2. Now, we can't solve this as it sits because it doesn't tell us what to solve it for. So let's pick a variable. Let's solve for x again. So if we aren't told what to solve for, we can't do anything with it. So let's go for 2. Or first we have to undo this dividing by 2. So to do that, we're going to multiply both sides by 2. So that's going to give me 2z equals, this 2 and 2 will cancel, negative 6x minus 3a. Got to get rid of this minus 3a by adding 3a. So I have 2z plus 3a is equal to negative 6x. And not done yet, need x by itself, so divide by negative 6. Now I need to divide this whole side by negative 6. So this whole side must be divided by negative 6. Now we can do that, so these will cancel out. X equals 2z plus 3a divided by negative 6. I could leave it like that. It's not simplified, so we can actually simplify it. If I rewrite it here, I have 2z plus 3a divided by negative 6. If I look at these as fractions, so I have a 2 over negative 6, that would reduce to be 1. I'm debating if I should put the negative. I'll put the negative up front. Over 3z plus, now I look at this fraction, 3 over negative 6. That's going to give me negative 1/2 a equals x. So we could write it like that as well. Or, yeah, we'll leave it like that. So these would be our final answers. All right, I got two more. Number 5. Here, we're solving for x. This was a trick. This is all multiplication. So what we can do here is we can actually divide by this whole factor here to get x by itself. So we can divide by c times r minus d. This would cancel with this, and this would cancel with this. So on this side, I have m divided by c times r minus d. My final result would say x equals m divided by c times r minus d. The last one we're going to look at, we'll hopefully try to get this done quickly. We're going to solve these equations for y. We're going to solve these for y. So first step would be to add 6x on both sides. So that's going to give me 2y equals, now I can write 10 plus 6x. I like to have my variables first, so I'm going to write it as positive 6x plus 10. That would be the same thing. Divide by 2. Remember to divide the whole side by 2. So I have y equals, I'm going to do 6 divided by 2, which is 3x. And then I'm going to do 10 divided by 2, which is 5, just like we did before. But this time we get nice numbers, so we can write it out as so. Oh, and you didn't see that. Y equals 3x plus 5. Last example, we got 30 seconds. Keep it under 7 minutes. So I'm going to draw my line. I'm solving for y again. So I'm going to take away 7x. Take away 7x. Leaves me with negative 4y equals, I'm going to again arrange my variables first. So negative 7x plus 24. And then I got to divide by negative 4. To be really careful here. Y equals negative 7 divided by negative 4. It doesn't come out to a nice integer, so I'm going to write it as negative 7 over negative 4, but I'm going to cancel out the negatives. So it's just going to be 7 fourths. And I'm going to leave my variable x. The x isn't on the 4, it's just in the term, so it's 7 over 4 times x. And then I'm going to do 24 divided by 4, which will give us 6 plus 6. And this would be my final answer for that equation. And that's a quick reminder of what we do when we want to solve literal equations for an indicated variable.